for the All right, thanks for the introduction, Wes. So let me get this slide deck going. I want to make sure everybody sees my slide deck. Good.
You're good.
Awesome.
Yep.
Okay, yeah. So as Wes said, my name is Alex Berger. I'm a senior TME for the MS product platform. I came to Meraki about 5 years ago as a field sales engineer working with Wes, and prior to that, I was actually in post sales deploying like ICE, wireless, switching, routing, ASAs, all sorts of fun stuff. And so I've been around for a bit, and I really enjoy security. It's a kind of an area of interest for me that has not gone away, even with all the products I've worked with. So I must be a glutton for punishment. So anyway, to move on here real quick, I'm going to go over a couple new things that we have announced with the MS product line. And a couple of them being going over mainly access security and how we're trying to enhance our platform. But before I get into specific features, I want to kind of cover why and some of the things that have been, coming up from our perspective, from customers, from feedback from the field, and a lot of the issues that that have been brought to attention to us is, that switching needs to be able to provide the ability to minimize vulnerability, try to limit the amount of exposure that endpoints and clients actually have on the network to potential threats. And if there were threats, be able to actually contain those issues and be able to take care of that problem without having to hire an entire squad of security folks to, get on top of it. Also be able to provide multi-tenancy so that you can safely and securely provide network access to different groups with different purposes on the network, as well as securing IoT devices. As we all know, you can buy an IoT device, quote unquote, for a couple dollars, and it may support Wi-Fi, it may support all sorts of things or not. And they also don't usually support security updates. And so being able to secure those IoT devices means that we can effectively use these pieces of technology without bringing a bunch of potential issues on the network. And then last but not least, we are always hit with how do we make sure that we meet HIPAA compliance, PCI compliance, and how do we, ensure that, that data is being secured, well. And before I get into the features still, I want to kind of talk through how we got where we are. As we all know, networks used to be simple. I've seen people deploy back in the day, especially, large 10/8s, 172.16/12s at a site, not realizing that you could actually subnet. And that was all because the network was meant to just connect devices. It wasn't meant to be a security structure. But as we add more and more features and functionality and services, we found out we needed to segment, and we needed to start giving voice devices their own VLAN, guest devices their own VLAN, so that they're segmented away even from just a layer 2 perspective. But as we tried to secure that traffic, that's where, using the network as a security mechanism became more and more difficult, because you have to build these giant access lists just to try to, restrict traffic between two hosts, maybe in a subnet, if possible, even as far as trying to, just provide the basic means of getting your work done to an end user. And as we add more and more sites, those ACLs grow and grow. And as we need more and more resource sharing, once again, they grow, and they're very hard to keep track of. I've worked with many customers on security audits, trying to figure out what the 1,000 lines in their firewall are for. And I can tell you that while everyone has the best intentions initially, the second someone leaves that owns that aspect of the network, you're in a bad spot, because not everyone puts remarks or comments on an ACL or an ACE in a, couple 100 line long, access list. And so how do we make sure that we can better understand, what is for what? Why are we blocking? Why are we permitting traffic? But not only that, how do we make sure that we restrict the amount of communication within a VLAN, so that if we have an IoT sensor and it gets some malware, and then it starts spreading that malware, today it's very difficult. You have to apply an access list. You maybe have to apply, a downloadable ACL. All sorts of different technologies have been built around applying an IP-based access list to a device. And while that can work out well, the one thing to keep in mind is that this doesn't always allow us to contain devices within a layer 2 network. And so with our classic MS portfolio, which is like our MS, 350s and 355s and below, we've tried to go ahead and get our security up to snuff. If you've worked with Meraki in the past, we've had ways of providing security on the network with .1x, with access lists that are system wide, but those don't give us a total control over that network. And so one of the first things that we're introducing with our MS Switch 14 release is our concept of group policy ACL. So one thing to keep in mind about group policy ACLs is they operate a lot like if you were to call out an ACL name with Radius or with 802.1x. So you can effectively utilize these group policies to apply different access lists, different inbound access lists on wired clients on a per session basis. One of the really cool things about this, though, is the fact that we can configure all of these policies up in dashboard and they get pushed down to the switches so that you don't have to rely on a communication mechanism any further than getting the access accept message back from the Radius server. So as a client connects to the network, they will get this ACL applied to them. And if you need to make changes, you can change that in dashboard and it will change that policy on the fly. So if you realize that like your guests were getting more access than they should, or maybe you've got some printers that need to have a port opened up, you can do that in one place in dashboard and be able to open up that ACL further. And not only that, but with .1x, we've been trying to make some enhancements towards being able to provide critical access to the network and being able to make sure that if you accidentally misconfigure a device, it doesn't get black holed and you have to go touch that device personally. So we're introducing in our MS or Switch 14 build as well, failed auth VLAN. And what this is if a user fails to authenticate, you can specify a VLAN that client gets put in, and we can call it a remediation VLAN, and allows you to potentially get access to that device to fix the issue. So if you're working remotely with an end user and they are not getting to the resources they need, you could validate, where they're connected and then get into that device without having them, exposed on the network or black holed if, for instance, their authentication had failed and it's a closed authentication scenario. And then this is another heavily requested feature that we are bringing as well, and that's critical auth VLAN. What this means is if the Radius server is not responding, so if a site loses access to the Radius server, today, if you were to re-authenticate on a switch, we did not have this feature, so the ports would get in a blocked state, and we would have to have access back to that Radius server to regain that network connectivity. With critical auth VLAN, what we can do is say, hey, if the Radius server isn't responding, automatically authorize the voice device, automatically authorize the data device behind that voice device, and make sure they can get access to critical resources. This is only applicable if the Radius server is down, but does allow us to have that fail-safe of not relying on that WAN connectivity to making sure users can connect to the network. Now, these are just ways we were trying to bring the existing MS platform up to speed, kind of give you the features that we've all been looking for years. And I want to get into where we're going towards the future here. So I want to introduce adaptive policy. I'd mentioned how access lists aren't fun to manage. And while, a lot of times they are required or they're a necessary evil, if you will, there's got to be a better way to provide that endpoint security. And so we have built this feature utilizing Cisco's security group tagging using inline tags. So what this does, and I'll explain this in detail in the next sets of slides, but what this does is gives us the ability to tag a client's traffic with an identity value and then be able to apply policy based on that identity source and destination. So we can say, hey, this client's an employee, this client's a contractor, they should not talk. They should not be able to communicate within the same layer 2 segment or even across layer 3 segments. But this gives us an organization-wide policy, and I'll demo this here shortly on what I mean by that. And then last but not least, as I mentioned, microsegmentation. Now, a couple things to keep in mind. To enable adaptive policy, from a switching perspective, this is going to be, or this is supported on our MS390 platform to start. So utilizing that Cisco ASIC, we're able to, and more so the UADP ASIC, we're able to, provide this inline tagging functionality because it is a new ether type and it is a new, kind of part of the packet, if you will, or frame. And then also, if you have just a wireless network and catalyst switching, you could just buy our 802.11 AC Wave 2 and up APs. But both of these hardware platforms do require that advanced license. So if you buy an MS390, you have to buy the MS390, port size dash advanced, and the same goes for MR. Now, when we talk about assigning tags, a couple things to keep in mind are we have about 4 methods to actually get that tag assigned to a client. There's like the static switch port assignment. This is for fixed devices. This could be, fixed locations. Maybe you have a port that's connected in a conference room that's publicly accessible. Being able to apply a static tag to that port means that anything that plugs into that switch port will get that tag. So you could easily apply like a guest policy or whatever it may be and be able to, still provide access off that port while securing it. There's also static SSID assignment. So if we have a guest SSID or maybe an IoT SSID, and we know that every device that connects to that SSID can get the same tag or should, we can statically assign a tag. Now, static assignment does work without a radius server, so it is a valid deployment scenario for customers that don't have a .1x implementation. However, our kind of recommended deployment, if you will be to utilize 802.1x. And the reason behind this is, if we use .1x to apply a tag, we can do it dynamically, whether it be through, looking at the posture of the client, profiling the device, validating that the user has the right credentials. All sorts of great things can be pooled together to determine, what that device's identity is and what they should get from an access policy on the network. And so with wired and wireless, we are supporting 802.1x as a method to apply tags. And then there's also our static prefix to SGT mapping. So what this is if we have, for instance, an entire subnet where we just want clients to, when they're in that subnet, get the same tag, you could apply, that subnet to an SGT. There's also situations where, let's say we have servers in a data center that we don't necessarily manage end to end, and we can't get tags into that environment. So you think like any managed services where maybe you have a VPN to that site or even AWS. You could easily go in and instead apply an IP to SGT map. So you could say, this server is a DNS server, apply the DNS server tag. And then at that point, be able to use that IP to SGT map as a method of applying policy to your clients so that when they are attempting to, for instance, communicate out to that service, be able to provide granular control over that communication. But all of this comes down to being an org-wide policy so that when you set up your policy, it covers all of your sites. So you set it up one time, and as you make changes, that policy gets synced down to every node in the network that has adaptive policy running, so that you don't have configuration sprawl where you've got site A with the ACL that you initially set up, and then site B, you updated it and have to go back to site A, update it there as well. This gives us one place to configure policy. And as I mentioned earlier, we do have like group policy ACLs on switching, and we have group policies on our wireless platform, as well as group policies on our MX platform. So how is this different? So the one main reason that this is different is the fact that these tags are IP agnostic. So we don't have to worry typically about the subnet that the client is in, the source IP address that client has. All we're looking at is the tag information to apply policy itself. Because in the end, the goal is to provide powerful automation with this security feature set so that you can go in and create your policy and have that policy useful across all of your networks. But also make sure it's effective. We're using Cisco's inline security group tagging because it is a very effective security mechanism that has been around for a while and is utilized in a ton of Cisco products. In fact, most network access products from Cisco support tagging now. And you look at, in the end, the other goal is to try to make sure that we don't cost you a ton of money when you're trying to deploy security. I've been, in many situations where we go out to a customer site and they tell me the policy they need, and it's crazy. Like, they want to block everything and only permit like 5 resources to a client. And historically, that takes way more time than you'd ever want it to. It can take weeks, months, years, sometimes never gets done. And so really trying to make sure that deploying security is something that isn't the most difficult process on the planet. Let me go ahead and get into my demo here real quick. Wes, did you want to, are we doing any like Q&A before I keep going?
Yeah, so why don't we pause here? Yeah, as so you have the demo ready to go. But Michael, I'll defer to you. Do we want to pause for a second? And Alex covered a ton of ground here, right? Kind of doing a historical look back, doing a quick update on outside of kind of this next gen tag based architecture, how we've been really filling in that gap from on the classic MS line for some of those advanced .NET features, group policy ACLs, the critical auth VLAN. So I'd imagine there may be a question or two out there, but Michael, just defer to you to see if you have anything, or if you want to kind of turn it to the audience while Alex cues up his demo.
Oh yeah, for sure. So there weren't any questions that came in through chat, but definitely again, feel free to ask any questions via chat, and we'll address them. But no, nothing was submitted.
Cool. All right. Well, let's get into a demo. So as I mentioned, adaptive policy is an organization-wide feature set, and especially from a policy definition perspective. And so instead of going to a network and finding an adaptive policy tab where I have to set up all of my policies and try to figure out how to get them to match everywhere, we're going to navigate to organization and adaptive policy. Now, the first thing we get to with this organization adaptive policy is our groups of SGTs. So we have the ability here to define different classifications for endpoints. Now, this is my test environment / home network lab / lots of things. So there's lots of random tags in here, but an example of this would be like IoT device. So you can see here we have this IoT device with a tag of 10, an IoT server with a tag of 11. And so the whole idea behind this is that when we have an IoT device connect, we can classify it with this tag of 10 and then carry that tag through the network on a device by device basis and be able to apply filtering based on that identity and be able to apply a policy, for instance, from 10 to 11 or from the IoT device to the IoT server. So once I've actually defined my tags, the next step is to enable the feature on a network. And so as you can see here, I've got a couple networks where adaptive policy is enabled, but all it takes to enable this feature set is to put a check mark next to the network and then click enable. And what happens in the back end is dashboard goes and looks at the software versions, firmware versions on the devices, looks at the licensing, looks at the models, and makes sure everything is good to go before enabling this feature so that when it is enabled, we know it's going to function. And if it isn't meeting or isn't up to snuff, be able to provide an error explaining what's going on. So once I have this feature set enabled on a network, we can go in and start classifying traffic. And so for instance, if I navigate over to switch and switch ports, we have 2 different means of applying tags. So we have here's an access point plugged in. So if I wanted to make sure that I was propagating tags to this access point, all I need to do is select on the interface that it's a trunk, has peer SGT and capable enabled, and then setting our infrastructure tag, which is our network device to network device tag on this interface. And what happens in the backend is that these devices then not only keep the tag applied to the client traffic and send it up to the next hop, but also make sure that we trust the tags coming from that device so that if an AP is tagging a client's traffic and sending it through to the switch, we trust that marking and we preserve it through the network. Now, let's say we have like a wired client, and I mentioned, the static tagging functionality. we could easily come in and select another port and select an adaptive policy group. And as you can see here, this is a list of all the groups that I created at that organization level. And so in this case, let's say I wanted to apply, let's see, the SGT of 10 to this device. Anything that comes into this switch port, and this is something to keep in mind, whether it's a voice device, a wired device, or client device, an IoT device printer, will get this tag. So static assignment is very rigid in that everything gets the tag of 10 on this interface. But all I have to do is click update, and that interface config will be in play, and traffic will start getting tagged. Now, that's from a switching perspective, right? So we can easily apply it statically. I guess one thing I forgot to mention is we could also instead select an access policy. Maybe it is I have an ICE server that I want to, or a cluster of ICE servers that I want to authenticate clients and give me that dynamic tag. We can do that easily just by selecting the access policy, and then at that point, expecting the Radius server to tell us what tag to use. That's all it is from a switching perspective to classify traffic. There's no requirement to go in and build complex policies on a switch-by-switch basis or on a network basis. So at that point, we've classified traffic from a switching perspective, but from a wireless perspective, we can easily go in to access control. We have this SSID here that's currently a pre-shared key SSID. If I scroll down the bottom here, we can select what group we want this SSID to take on. So as you can see, I've got the tag of 30 assigned to this, this SSID. However, if we were using anything with Radius on this, so if we were using Mac-based authentication, enterprise with my Radius server, or identity PSK with Radius, where we can use the Radius server to send back a pre-key per client, we can also send back a tag. So we can override that base tag on the SSID so that if you have users that need more access or more privileged access to the network, you don't have to build multiple SSIDs to provide that security policy. Now, once I've actually classified my traffic and I have clients getting tagged, we need to be able to apply policy. Once again, organization-wide policy, I'm going to navigate back to adaptive policy at the organization level. And I'm going to navigate to the policies tab. Yes. So this is a new UI. We've been adding more and more functionality here, but under our policies tab, we can actually see what policies we've created and what policies are in place. So you can see here we have a ton of policies for our IoT devices. We have some custom policies that I'll show here in a second. And this gives us a good overview of just what we've configured and what's actually in place. But let's say that I actually want to add a policy. I'll click Add Policies up here. And now we have a list of our source and our destination. I'm not going to apply this policy that I'm going to create here because this is my home network and I could end up dropping myself off the network because of what I'm about to do. But we could easily, for instance, if our IoT devices were compromised, we could select all here and deselect server and click deny. And what this is going to do is this is going to deny the IoT device from talking to anything else except for my IoT server. And what that does is, so no matter where IoT device is plugged in, as long as it's getting that IoT tag, we can easily provide that segmentation between these two different tag groups or many, many different tag groups and just permit access to our IoT server. But we might not want to apply full access to our IoT server. So I could easily select IoT servers here and click custom. Now what this does is this allows me to specify a policy that isn't just permit or deny. We can start specifying things like what ports should I be allowed to communicate on. Now, I have a lot of MQTT devices, so I have a rule in here to allow MQTT ports. So maybe I know for a fact that my IoT devices only need to use MQTT to communicate to my server. Any other actual traffic would probably be potentially nefarious, you never know. But maybe, let's say I need also to allow for some REST calls, I could permit HTTPS, and then deny everything else. Now, once I click Review Changes and Update, what happens is the communication between the IoT devices and the IoT servers is now limited to only those MQTT ports, only that HTTPS 443 port, and that is it. And so what that does is gives me the ability to not only permit or deny traffic, but also control communication between two endpoints. Now, if I needed to, I could easily go in, make a policy change, and upon that policy change, have that config propagate out to all my sites so that if, for instance, we had a device get compromised or a group of devices we think are compromised, we could go in, apply a policy, and do it in one place in just a couple clicks and have that policy propagate everywhere. All right, so let me get back. Go ahead.
Yeah, so Alex, just a couple things that kind of come to mind as you're going through that workflow. I love the precision of explicitly granting access and just enough access, right, for this source group to this destination group. But one thing that I know I personally can easily overlook is like, well, we've also also solved for that issue of basically microsegmentation, right? So if we have a group of IoT devices, not only have we only permitted a given IoT device to talk to an IoT server, but we've also simultaneously prohibited them from talking amongst themselves, and thus solving for something like a worm propagation within, say, a VLAN, which would be a typical problem. So it feels a little bit like allowing this, VLAN to talk to that VLAN, but it's inherently different in that it is truly only a device with this tag can talk to a device with this different tag, and thus I've eliminated, intra-group communication.
Yes.
Yes. To me, this right, and I'm kind of like, I'm the first one to admit that kind of look past that because we're so used to kind of having this group of users, and they typically can talk amongst themselves, and okay, that was okay, and at least we've eliminated them from talking to any other group except for this, say, IoT server group. But it's really much more surgical, and I think this is really like a great real-world example of delivering not just against the ability and to use Cisco's SET technology, which has been around for a while. We've kind of unlocked that feature, if you will, but really this is completely in line with the industry trend and something that Cisco has been right at the heart of around zero trust, which is, hey, I'm going to vet you as you approach my network, and I'm going to grant you only the amount of access that you truly require in order to do useful, productive things, and nothing more and nothing less.
Yeah, I mean that's a good call out. A lot of these initiatives we have behind our security enhancements, and as we keep moving forward, are designed to help make zero trust something that's actually not super difficult, and maybe more so make it something that you can deploy quickly and at least start getting yourself into. I will say, talking about zero trust, when I refer to dynamic tagging, that's something where zero trust fits in, or where that dynamic tagging fits in with zero trust. And I'll get into a little bit of how this operates with like Cisco ICE, et cetera, so that you kind of understand the inner workings there. But before I do that, I do want to cover a little bit more information about what SGTs are, because while they have been around for a while, they still are foreign to a lot of folks, or they have been, just seen it at a high level. And I kind of want to just walk through what they are. So an SGT is actually a new layer in the frame that is transmitted between two devices that understand this ether type. And so as you can see here, it comes between typically the source MAC and the ether type before the payload. So the CMD portion of the actual frame has a number of different pieces, but there's one piece that we truly care about, and that's that SGT value. It is a numeric value. So if you're looking at a packet capture, you're not going to see employee or IoT. You will see a numeric, ID in there. However, what that does is that's why we have you create that ID to name mapping. But that's how we actually transmit the source device's identity in the data plane. So there's no need for this control plane connectivity, out-of-band connectivity to tell each network device what device is what device has what tag. It's all propagated as a client creates traffic. And this is something that needs to, I highly recommend trying to commit to memory. You have to have end-to-end tag preservation, AKA you have to have end-to-end support of SGTs to perform microsegmentation, like within a VLAN, or granular control over two endpoints. If you have a device in between that doesn't support SGTs, that packet, part of the packet, does get stripped off. And so this is very important, that to understand that you have to carry that tag all the way through the network to the destination to be able to enforce policy. And it seems silly, but what this does is gives us a lot of scale on how many policies are implemented, and more so, how many clients are using that policy. So instead of relying on building these monolithic ACLs that keep growing and growing and taking away more and more TCAM space, we're able to apply an identity tag to a client and then carry it through the network until the network device that's performing the actual security feature set knows the source tag and the destination tag. And once it knows both tags, it's able to apply that policy that we've constructed. And so just to reiterate, you don't see tags between the client and the network device. They have no idea these exist. This is purely a communication mechanism between network device to network device. And so as you can see it highlighted here, we're only going to see that encapsulation when an access point is tagging traffic to a switch, or when a switch is tagging traffic to another switch. And even further into maybe a switch is transmitting traffic to a firewall. And so just keep that in mind, that like if you were messing with this feature, kind of getting to check it out, if you do a packet capture on the client side, it looks like nothing is any different. So anyway, just talking about those port configurations and the behaviors, this is fairly relevant. I've noticed, over the last 6-8 months of talking with customers, talking with engineers on this feature set, that it is good to understand what happens when you configure a specific setting on a switch port. So when I had mentioned that the connection between an access point and a switch, or a switch to switch, or switch to firewall, that peer SGT capable function is required for us to propagate tags. And as I mentioned, this trusts the tag that comes into that port as well. So as an access point is tagging a client's traffic, it's going to trust those tags. It believes that the device tagging that traffic is a trusted source of authority. If any traffic is untagged, and this is typically going to be like maybe some control packets from a switch or control packets from an access point, it will actually remark that traffic with that SGT of 2. And this is for mission critical services like OSPF, or maybe BPDUs from a spanning tree perspective. And so we want it to be able to remark those packets. That's why we select that SGT of 2 on that interface. And one thing to keep in mind is this is only available on trunk ports. So on access ports, we're only going to allow for traffic to be tagged, but on trunks, we can also allow encapsulation. And the one thing to keep in mind on .1x is that when you enable 802.1x on an interface, you can't statically tag a client's traffic. You do have to rely on that radius server to send back a tag to use. So if you do test this out and you are looking to deploy this and test .1x, the radius server does have to send an SGT. Luckily, it is just an attribute. And so when you need to send a specific SGT back to that network device, it just has to have this Cisco AV pair. Now, the one thing that I don't understand to this day, but is what it is, we decided to use hex values. This is across Cisco. So while we could have put in like 4,000, we decided instead to put in 0FA0 as the SGT. So if you're building these policies and you're not using Cisco ICE, you're using another radius server, just keep in mind you do have to convert that actual value to a hex value as you're sending it back. Now, one of the things as well to keep in mind is that we are performing policy a little bit different than other tag-based security environments, in that we are having you specify your entire policy at the organization level, and each network device downloads that entire policy. Where this is very useful is that you don't have to wait for a policy to get downloaded on demand. You don't have to wait for after a client authenticates for the radius server to tell me what the policy is. That policy is there. so that even if you lost network access or you lost connectivity to your Radius server, you can still apply policy in the same way and without any latency added to that connectivity or to that security being enforced. This also means that if you didn't want to use dynamic tagging, you can do it all statically without having to rely on another entity to provide policy on demand. So we are only going to support 60 tags. We're looking to increase this up to 100, but as of right now, we're limited to 60 tags. And this gives us a maximum of 10 custom ACLs on a tag-to-tag basis. So when I selected IoT device and IoT server and I clicked custom, I could have had up to 10 ACL lines in that list. So that doesn't mean aces. You could have 16 ace entries per ACL, but I can only compound 10 of them on there. So if it was MQTT, HTTPS, DNS, DHCP, just be cognizant of you have a limit of about 10 at launch. Now I wanted to bring this back up again, but endpoint scale is not based on this feature. So we're not limiting you on the number of endpoints that we can support. That's actually going to fall back to the hardware support for that platform. So if you look at an MS390, we can support up to about 32,000 MAC addresses in the CAM table. So we're not limiting you on, I've got 150 clients in this network and I can only support 5,000. It is purely based on that hardware limitation. So we didn't just build this feature to work with Meraki, and we didn't just build this feature to work within the Meraki ecosystem. A lot of why we went with tag-based security is because Cisco has made this feature very prevalent across all platforms, and most of our customers don't just have Meraki. So I mentioned that we can easily propagate tags to another network device using that SGT-capable trusting configuration on an interface, and that's very doable. So we can easily share the identity of a client in a Meraki Adaptive Policy domain to any other Cisco tag-based security domain. But there's one piece that is kind of difficult, and that is how do we make sure that the policies match between that Meraki Adaptive Policy domain and, let's say, a TrustSec architecture. So one of my coworkers actually developed a Docker container that is free and open source that will sync policy between Meraki's adaptive policy construct through the API to Cisco ICE and vice versa. What this does is gives us a lot more control, or more so central control of policy, so that you could make something the more or less source of truth, whether it be the ICE server is source of truth or dashboard. So maybe it is that you want to deploy this feature set and you have a security team that manages your policy. If you use this sync container, that policy can get synced from ICE to dashboard and do so not only on demand if there's an update or change made, but also do it in increments or in intervals, so that if you have policy configured and someone makes a policy change, we can make sure those policies are in sync. And especially if you set ICE as the source of truth, then you don't have to worry about going into dashboard and making configuration changes. So with having that sync container, we're easily able to utilize ICE to actually have that policy built and then make sure it's reflected on our network devices, so that we can connect to TrustSec domains. So if you have a TrustSec architecture already built and you're already using tags, but you wanted to utilize Meraki as well, being able to sync those policies, make sure that we're carrying that tag traffic through from Meraki to Meraki Adaptive Policy to TrustSec and vice versa. We also are working on the Meraki Adaptive Policy feature set, allowing us as a policy extended node to an SD access environment. So for those of you that are not familiar with an extended node, what it is a non-fabric device that's able to bridge clients into fabric VLANs or fabric address pools. But with the inclusion of adaptive policy, we can allow a policy to get from that adaptive policy environment into the SD access network. So it may be that you have a large SD access campus, but you have outbuildings that you don't want to put a large switch in. You have outbuildings where you need Meraki access points, or maybe you like SD access from a campus fabric perspective, but like Meraki wireless. We can easily provide that tag, propagation into the SD access network and back out from the SD access network into the Meraki device and be able to perform that same granular policy. And then this is actually an interesting one, and having worked with many, many firewalls and school districts, hospitals that have needed to apply granular permissions over access to the internet, access to resources. The other aspect of this feature set is being able to, for instance, propagate tags into a firepower appliance. If you've worked with firepower before, or even ASAs for that matter, actually, but firepower's a little newer. But if you've worked with the Cisco firewalls and firepower, you can easily get tags from the Adaptive Policy Network by establishing that trust connectivity between those two devices and be able to use that identity tag to perform policy. Now, the cool part about this is if you're trying to do like content filtering and doing it based on the users group, you have to potentially integrate with Active Directory. You may have to integrate with the Radius server to track the accounting logs. You may have to do all these crazy things just to do something as simple as this guy can get to gambling web pages and this guy can't. Well, instead of spending all that time and having all of that out of band control plane traffic, you could easily go in and utilize SGTs to provide that granular filtering policy, so that an SGT of 100, let's say that it's an administrator, but SGT 200 is a guest, you're able to provide different filtering and different access to different resources external to the internal network environment. So in the end, our goal is not just to provide security within Meraki and security within the Meraki platform, but also be able to provide that multi-domain experience where a user can plug into an adaptive policy domain or into a Cisco tag-based domain and be able to get that same experience and that same level of security that you would want to expect from this entire feature set. And that concludes, I think, me talking for 45 minutes. So
fantastic, for sure. And at this point too, guys, if there are any questions, I mean, if you do want to come off mute and ask a question, feel free to do so. We do have about 10 minutes left, so. But no pressure, obviously. Or if you want to ask in the chat. But while we're waiting to see if there's any questions, just a reminder again that we will be sending out the recording after this concludes, and we will be also having a follow-up session next week focusing on enterprise network design, focusing specifically on Meraki and environments that also leverage Cisco switching as well. And lastly, the MetroPhillySelect.com site. There's a lot of training opportunities there, and the newsletters and webinar videos and everything will be posted on that website. So if you are looking for any follow-up sessions or want to check out that page, feel free to do so. I do not see any questions. So with that, I will close out this session, and thank you so much, Alex, for your time today. Thank you, Wes, and we will see you hopefully next week. And I appreciate it.
Awesome.
Everyone,
Thanks,
have a great
everyone.
weekend.
Thank you.
Thanks, guys.
Thanks so much, guys. Have a great weekend.